Okay, so sorry I had to finish off kind of quickly in my last video because I ran out of time. So we left off at this point. We had figured out that theta is 20 degrees. So we're not quite done yet. We have a little bit more work to do. So let me just draw out our final vector again. So we had 14 in the south direction, 38 in the east direction, and then we had already figured out that this is 40 kilometers. This is our final vector. And we know this, we just figured it out, it was 20 degrees. And this is 90. So this is what we have so far. We just have a little bit more work to do. Okay, so it's good, we know this is 20 and this is 90. Unfortunately, this is not the angle we're looking for, although it will help us to get the final angle we need. We are actually looking for this angle right here, so let's just call that alpha, just for a different notation. We're looking for this angle because this is the angle that is made between your south direction component and your east direction component. So we need that angle, the angle that's made between your south and your east, right? So we need this angle. So we can find that out really easily. You know the sum of angles in a triangle. I mean, this is really easy stuff. Sum of angles in a triangle is always 180 degrees. Bam. That's the easiest rule that you will ever come across. So we have, let's say we have angle number 1. This is going to be my notation for an angle. So we have angle number 1 is 20 plus angle number 2 is 90, right? So, and plus we have angle number 3, which is what we're looking for, equals 180. So really easily, 180 minus 110, because that's 90 plus 20 is 110. So that would give you 70 degrees, which is your angle 3. So that's your final angle right there. Your final answer would be 40 kilometers. So that's your DF, 40 kilometers. It's going in the south direction at 70 degrees, and it's going east as well. So this is the right answer. Please make sure you don't write this as 20. That's not the angle we're looking for. Alpha has to be 70 degrees in this case by figuring this out. So this is 70. So this is how you do 2D vector problems, and as you can see, they're super easy to do if you just go through step-by-step process that we went through in video number 1, and then in this video you're going to get the right answer pretty much every single time. So make your table, you know, list out your x and y components, and draw out your components nicely. You know, always draw out a nice diagram which you can follow. You know, name your vectors in a logical manner so you can follow through properly, and you know your trig rules. Please know your trig rules. Again, if you're not comfortable with trig, leave a comment in the comment box, and you know, we can always go through a video if I get enough comments for that. But essentially, this is it. This is what 2D vector problems in physics are. Obviously, you can use this is the basic. This is the basic problem. You can obviously use this and apply it into more complex questions, and you know. So, but as long as you know this, you'll be fine. So hopefully you enjoyed this lesson, and you know, you got to learn a little bit more physics than you knew before the video. And let's see what I make for my next video. You know, it might be physics or chemistry, so watch out, and I'll see you guys next time.